Hi everybody, Steven here. If you ever wondered about vSphere's virtual networking and you're not quite sure about their failover policies, what's a standard switch, what's a distributed switch, all that kind of stuff, stick around. We're going to cover all that. See you in a bit. Hi everybody, thanks for sticking around. So what we're going to do in this episode is we're going to continue on. The last few episodes we talked about what virtualization was, installing ESXi, installing our vCenter server. Now we got to get into the networking and next into storage, and then we'll really start getting into like creating VMs and cool stuff like vMotion and all that. But we got to get these ground stuff first. So let's talk about networking, and that's what we're here to do, right? So I'm going to talk about standard switches, distributed switches, and a bunch of the features of it. So this is going to probably be a bit of a long video. By the way, if this is stuff you're interested in, please subscribe to the channel. Without subscribers, there's no content, and it helps bring content to the channels, okay? So thanks very much. If you've already subscribed, I really appreciate it. So let's jump into it. So what we're going to do here, oh, this is what I want right here. I got some lecture components here and some demos. Like I said, this is going to probably be a long one here, right? So let's talk about virtual switches. So first of all, why do we need virtual switches? Well, remember, a virtual machine has a virtual NIC. That virtual NIC needs to get outside to the real world somehow, right? Well, that's what these virtual switches allow us to do. There's other things these virtual switches allow us to do. There's this thing called VM kernel services. There's stuff like, well, how do I manage my ESXi host? How do I mentioned a thing called vMotion, and how about storage, like IP storage? How does all that talk to our host? Again, we'll take a look at, and this is where virtual switches come into play as well. There are two types of virtual switches. There's the standard switch that comes with your ESXi server. There is the distributed switch, which is a licensed feature. You need vCenter server, and it has to be pretty sure it's Enterprise Plus. Anyways, so it is a licensed feature. All right, so we'll take a look at both of them. Okay, so here is our standard switch, our vSphere standard switch. The gray box represents our ESXi server. So that's our physical host machine. Inside our physical machine, we have physical network cards. So I've got two of them in this picture. You could have more, obviously. We represent those cards as VMNIC 0, VMNIC 1. It's actually not capital VNM. It's just VM lowercase VMNIC 0 and VMNIC 1. Anyways, so those are lowercase. Doesn't really matter. So we see these physical cards. Now, when we look here, we're going to have a virtual switch. This virtual switch, when we prepared our host, there is a virtual switch that's automatically created for us. There's the first one. All right. Now, on this virtual switch, we have these uplink ports. These uplinks is what links to our physical network card. So in this example here, I'm linking to my two physical cards, and these physical cards go to the outside world. It's the real world, okay? The real world, all right? So we have these uplinks. So basically when you'll associate your virtual switch with a physical card. Now you can actually before I even go down that road, I'll demo that. Great. Now on the virtual switch, you'll have a thing called port groups. These are virtual machine port groups in this example. Port groups are, well, let me think, they're groups of ports. Now, remember, your virtual machines have a virtual NIC. These virtual NICs plug into the virtual ports on the port groups of the virtual switch. So in this example, I've got a production port group with 3 VMs connected to it. I got a test port group with a couple of VMs connected to it. Great, so you could do something like that. On these port groups, I could change the behavior of it. I could put traffic limiting if I wanted to. I could put VLANs and stuff like that. So I can have different security postures on each of the different port groups if I want. Now notice over here, we've got this other port group called VM kernel port groups. Let me clear this up. Our VM kernel port groups. VM kernel port groups are special port groups. It's basically you assigning an IP address to the host. That's one, and it's going to be used for something. For example, when we first set up our ESXi server, if you watch that video, after we started to configure it, I gave it an IP address. By default, it grabbed a DHCP, and then I gave it a static address. Well, it automatically created a VM kernel port group called management. And this is how, and that would have been connected to my first NIC, because I told it, yeah, I want to connect it to VMNIC 0. So by default, it would be connected to there. And that would be connected to some kind of management network. So hopefully you have some kind of dedicated management network for management traffic only and nothing else. Okay? And I'll show you that, okay? Now, I could create other VM kernel port groups if I want to. Well, why would I want to do that? Well, there are particular reasons why you might want to do that. One could be for IP-based storage. One could be for, in this example, vMotion. One could be for vSphere's fault tolerance. There's a list of reasons why you may create VM kernel ports to do certain things. Okay, and we'll talk about that as the series goes on. Maybe I'll create one for my IP-based storage, that sort of thing. So we'll talk about some of those examples as we go forward. So just keep in the back of your mind, you got two types of port groups. You got a virtual machine type port groups that virtual machines use, and you got a VM kernel type port group, which you could use for stuff like vMotion, management, all that. When you create a VM kernel port group, you've got to give it an IP address. All right, and you'll see that. I'll kind of go through and give you a quick demo. Actually, you know what? Why don't we do that right now? So, yeah, let's do that. Right now. Let's take a look at what I've got already created. So, let's go to my environment. So here's my first host. That was that. Okay, so let's click on my host right here, my host 1. I'm going to go into Configure, Networking, Virtual Switches. You'll actually see I actually have a virtual switch created here. It's called a Standard Switch vSwitch 0. Okay, that was created when I set up this host. Notice it's got a management network. There's a port group called Management Network, and it's a VM kernel port group. So it says VM kernel ports, and you'll see over here VMK 0. 172.20.10.51. That's the IP address I configured on this host a couple videos back if you're watching that. It is linked to the physical card VMNIC 0 over here. Notice I only got one card there. I don't have two, so I have no redundancy for my management network. We'll talk about redundancy later. Then there's also there's a port group here. This is a virtual machine port group. You'll see it's called VM Network. This was automatically created for me as well during my setup of my ESXi host. And then if I open this up, you'll actually see there's my virtual machine, my vCenter server. Again, if you watched that video, me deploying my vCenter server, I told it to connect to this network, this virtual network, right? So these two are automatically created for me. Let's go to host 2, and you see host 2 has the same, and host 3 has the same. Those are fresh installs. I didn't really do anything. I just installed it, boom, boom, and that's it, okay? Now, let's go back to host 1 here. I could actually go in if I want to, and I can say, maybe I want to do redundancy here, right? I can go manage physical adapters, and you'll see over here VMNIC 1, see it says unclaimed, it's not used. I can say move down, and I can actually have it as part of the active adapters, or I can have it as a standby. I'll talk about redundancy later. I'm going to cancel this, okay? I can go in and add networking if I want to. So I can say, well, it's asking me, what do you want to do? What kind of connection do you want? Do I want to do a VM kernel adapter? Maybe I want to do something like vMotion. So I got to set up a VM kernel adapter. We'll talk about that in depth. If I go next, it's going to say, select a network. It's looking for distributed switches. I don't have any. We'll show you that later. Let's say, select an existing standard switch. I only got the one, so I can actually say, I'm going to create another VM kernel port group on switch 0. Let's just go ahead and do it. What am I going to call it? Maybe I'll call this vMotion, just for argument's sake, right? I'm not going to worry about VLANs and all that stuff. I'll say it's for vMotion. I'll go next. I'm going to say grab an IP address automatically. I'm not going to do static. I'm just showing this as a demo. I'll go next. The summary, I'll go finish. And then I wait, give it a sec, and you see it just popped up there. A port group called vMotion, and it's a VM kernel port group. And it'll get an IP address eventually, or it should. Anyways, I should be able to grab one off my DHCP server. You know what? I don't want that there. I'm going to remove it. So I just wanted to show you I could have actually add multiple VM kernel port groups on here if I want to, if I'm if I need that, or if I want to add another port group. Let's go and again add networking. I want to add a virtual machine port group. So I'll go next. It says, do I want it on an existing switch, or do I want to create a new switch? Okay. So I'll say existing. I'll pick that switch here. I'll go next. And then we'll call it, it's asking me what's the name of the port group. I'll call it production. I'm not going to bother putting a VLAN. We'll talk about VLANs later. It gives me the summary. I hit finished. Give it a few seconds, and there we go. I now have a production port group. I could move my vCenter server over to that if I wanted to. If I right-click on this, edit settings, I'm not going to do this. If I go in here, VM network, sorry, let's cancel. I'm going too fast. If If I go to my network adapter, this is my virtual network adapter for that VM. Down over here, I browse my networks. You'll see there's production. I could select it, and it's going to go on that port group. I'm going to cancel that because we're not going to do that. So I can do stuff like that. Or if I want to create another switch altogether, if I go into add networking, again, it's the same kind of dialog box here. What do you want to use it for? VM kernel, a virtual machine. A physical adapter means, do you want to assign a physical adapter to an existing switch? That's really what it is. I'm not sure why this is there. It's confusing. But anyways, just worry about the top two. I'm going to say I want to do a virtual machine port group. We'll go next. And I'm going to create a new switch. And I can define its MTU size, maximum transmission unit size, if you want to use like jumbo frames. Notice it says this is the only unclaimed adapter, VMNIC 1, right? So so I could basically select that. I have to basically move it down. Now, this is interesting. So right now I've selected VMNIC 1. Me selecting this doesn't mean it's been selected. I have to move it down into the active adapters area. So if I do that, it's now my second switch. Will use that second card if I want to, right? Let's do this. Let's not select that card. Let's leave it unclaimed. I'm going to go next. It's going to come up and complain. There's no active physical adapters for the switch. Click OK to continue or cancel to review your changes. I'm going to say OK to continue. I'm going to say next. Back up. Sorry. It's asking me what port group do I want here. I'll call this production 2, whatever. And again, I can specify the VLANs. I don't care about that. And then it gives me a summary, and I do finish. And I give it a few seconds here. Here's my second virtual switch. And this is really interesting. Here's a port group called production, so VMs could go on there. But there's no physical adapter. So you might be wondering, what? That doesn't make sense. What I'm doing here, if I create a virtual switch that has no physical uplinks, that is an internal network only onto that host, which is kind of cool when you think about it. So I can create this virtual network running inside this host, and VMs connected to it can all talk to each other through the memory of the host. They can't get to the outside world, but they can talk to each other. There's actually uses for that, okay? But we won't go down that rabbit hole right now. So that's kind of neat, okay? So you do have that flexibility and that capability as well. I think that's it. That's good enough for this kind of demo anyways. I think it's good enough there, right? So let's go back to the material. So again, we'll talk about redundancy. I'm only showing, my environment only has the one NIC. We'll fix that up later on, okay? So I'll get into distributed switches. Okay, so now one of the things here, if you notice with the standard switch is managed on a per host basis. So a standard switch is unique to that host, and that's it, okay? Oh, by the way, I cannot create another standard switch here, vSphere standard switch, and use the same physical cards. It won't let you do that. So the physical uplink is going to be unique to each switch, okay? But a standard switch is a per host configuration. So if I had 100 hosts here and I want to configure all these standard switches, I'd have to go out to those 100 hosts and configure them all individually, one by one by one, or you could script it. vSphere came out with this thing called standard switches. This was years ago, back in vSphere 4.0. A distributed switch, again, is a feature of or a capability of vCenter Server. You have to be licensed for it. I'm pretty sure it's Enterprise Plus. Now, a distributed switch is just like it says. It's one switch distributed across all the hosts. So when you look at these diagrams here, you'll see up here, this is my vCenter Server. Up the top here, here's my host. I got host 2 and host 1 over here, and I got physical cards. And then you see these uplink ports. This can be very misleading, okay? A lot of people will look at this and say, oh, my data flows through these ports, and that's actually incorrect. This is management plane, what we refer to as management and control plane. Control plane. That means I manage the ports at the vCenter level. The data plane is down here on the physical hosts. So data flows down at the bottom here, not up at the vCenter server. So the reason why I'm pointing that out, some people will think, oh, if my vCenter server dies, my network stops working. That's not true. Think of how I think of a distributed switch is you're creating a template up here at the vCenter server saying, here's my virtual switch. And by the way, here's the hosts that will be part of that virtual switch. So the vCenter server is going to push the configuration down. It's almost like scripting your standard switches for 50 hosts or 100 hosts or something. So you could think of it like that, all right? So again, vCenter server manages the control plane and data plane, so the configuration of it, and it pushes it down to the host itself. And you'll see these, what they got, like proxy switches. So when you go to the host, you'll actually see the switches, virtual switches there. So, and it's technically, it's kind of like a standard switch that's been souped up. That's really all it is, okay? And I'll show you distributed switches in a bit. All right, let's talk about VLANs. Okay, so VLANs, so when we talk about virtual switches, we do support 802.1q VLAN tagging. There are 3 modes that you may or may not be aware of. We've got external switch tagging, which is EST, virtual switch tagging, VST. This is the most common one. And then you have virtual guest tagging, which is the least common of the 3. So let's talk about the first one. So external switch tagging, this was kind of popular back in, I would have to say, the around 2007, 2008 era, when virtualization was just kind of starting to really ramp up and people were working with this stuff. And what happened is, the server guys in companies were told, okay, you need to virtualize these things. And there was a lot of pushback, obviously, because anything new, people are going to push back. So there's a lot of pushback. And then the network guys would come in and say, oh, no, we don't want you messing with our networks. Here's your VLANs on these ports, go deal with it. So this was basically how things were done. So when we talk about external switch tagging, in this example, I got my ESXi host. I'm only showing 2 network cards, one network card for switch 1, one network card for switch 2, okay? I'm not showing redundancy, I'm not showing management networks, just keeping the picture clean, okay? You'll see on switch 1, I got a port group called production and a bunch of VMs on there. Switch 2, I got a port group called test and a bunch of VMs on there. Again, switch 1 is connected, it's uplinked to VMNIC 1. This physical card, I'll just say this physical card. Switch 2, virtual switch 2, has its uplink connected to the second card here in this example, okay? These cards are hooked up to a physical switch in the outside world. Now notice the ports on the physical switch. The port on the physical switch is basically, this is VLAN 10 and this is VLAN 20. Okay, so the switch is doing all the tagging and untagging of the frame. All right, so by doing this, all the VMs on this switch are on VLAN 10, and they're completely unaware of that. And all the VMs on this switch are on VLAN 20, and they're completely unaware of that. All the tagging and untagging is done outside of ESX. So this works great. There's no problems. One of the things here I do want to point out. If you've got a VM over here, let's say this VM on the left wants to talk to the right, has to come out of this switch, hit this physical switch, go out, hit a router out here. I'm not showing that in the picture. Go out, hit a router somewhere out here. I'm just going to assume this physical switch is layer 2 only. Hit a physical router, then it's got to come back in and then get routed up to here, okay? We don't do routing inside the host unless you get into NSX. That's a different topic altogether, okay? So great, we could do this. Again, this was fairly popular back then. I'd have to say it's not as popular today. The downside about this, for every VLAN you want, then you need multiple NICs. Again, you're going to probably want to have 2 NICs here for redundancy, right? So kind of wasteful, to be honest with you. But if you got a whole bunch of network cards, you could do this, all right? That was external switch tagging. Virtual switch tagging, this is more popular, especially today, right? Now, notice I'm only showing 1 network card, just so I'm comparing apples and apples, okay, folks? I'm not showing management networks or anything like that. Just, okay, you probably have 2 cards here for redundancy, all right? But let's just ignore that for now. So here's my host. Here's my virtual switch. I created my port group, and I demoed creating port groups there. So I created a production port group and a test port group. Production, I give it VLAN 10. test, I give it VLAN 20. So remember when I was creating my port groups, I could assign a VLAN. So I just type in VLAN 10 and whatever, VLAN 20, whatever. So now tagging and untagging of the frame is done at the virtual switch level. Okay. Again, these VMs, all these VMs in production are on the VLAN 10. They're completely unaware of it because it's getting tagged at the switch and untagged at the switch. Same thing over here on the right. The guys on the test port group are on VLAN 20. Now, in order for this to work, all right, in order for this to work, this switch, again, has this uplink connected to this physical card. And this physical card is going out to this physical switch. And there's the port there. Now, this port on that switch has to be set up as a 802.1q trunk. A trunk is a port that allows all VLAN traffic to go through. Now, I'm going to do this because I know not everybody watching this is probably a network person. So just bear with me for a second here. So when I talk about VLANs, let's say here's a switch, a physical switch. I'm only talking layer 2, just in case there's some guys out there saying, oh, layer 3, whatever, right? So here's, I got a couple of ports. Let's say I got computer A over here. I got computer B. These are physical, let's say. All right, so they're both on this port. Now, let's change the color. Let's say these two ports are on VLAN 10. And now I'm going to put computers C and computer D over here. And these are on port VLAN 20. So I go into the physical switch and I set those ports to VLAN 10 and VLAN 20 respectively, right? Now, computers A and B can talk to each other, no problems. Computers C and D can talk to each other, no problems, because they're on the same VLAN. So that's a set. The VLAN is basically a single layer 2 broadcast domain, so they could talk to each other. Now, if A wants to talk to C or B wants whatever, anybody, if the green computers want to talk to the red computers, they can't right now. They're on different VLANs. The only way to do that is to introduce a layer 3 device, let's say a router. So let me do something like this. I'm going to put a router here. I can put this port on VLAN 10 and this port on VLAN 20. I know some of you are probably freaking out right now, but just bear with me, right? So now I put this router, I got two interfaces on this router, and one's on VLAN 10 and one's on VLAN 20. So now at that point, once these machines have been set up, like the red machines is using this as its default gateway. Default, I'll say gateway, right? And the green are using this port as their gateway once you set that up. Now, these red and green computers can talk to each other because they're going through the router, which is a layer 3 device. So it can do routing for us. Now, this is really simple. I've got two VLANs. Suppose if I had 200 or 2,000 VLANs here, does that mean I have to have 2,000 ports on my router? No, that's crazy. So you can do something like this. It's called router on a stick. Again, some of you guys probably already know this, but not everybody knows the networking stuff, especially if you're just starting out new in this. All right. So this is a router on a stick, like a lollipop. Okay, it's the layer 3 device. Again, I'm now going to set this as an 802.1q trunk port. Trunk ports are special ports. When you set it as a trunk, you program in what VLANs are allowed to go through it. And you make interfaces on this router, like a sub interface and stuff like that. So trunk ports, you program in what VLANs are allowed to go through it. So now this router, it's a single stick router, can still do my routing between the red computers and the green computers. So that's what a trunk is, an 802.1q trunk, if you're not familiar with it. So that's why over here, I wanted to point that out. In order for virtual switch tagging to work, since we're doing up here, we have to have this physical port set as a trunk. So you got to tell your network guys, hey, set that up. So many times I've talked to my friends in the past and they're working on stuff and they're saying, yeah, I've set these VLANs, they can't talk to each other. And I go, talk to your network guy, is this port configured as a trunk? And they're like, I don't know. And I'll say, well, it won't work unless it is a trunk, okay? So you got to watch out for that. Routing, again, just to answer some routing questions, if a computer here on production wants to talk to test, it still has to exit out, hit that trunk. This is just layer 2. And then it's got to go out into your physical environment, hit a router, and then come back in to talk to like that, okay? Again, unless you're dealing with NSX, but watch my NSX videos. Great. External switch tagging, virtual switch tagging. Let's do the last one. This one's not that common. Virtual guest tagging. So the picture looks very similar to this one here. We got one NIC. Again, I'm just showing one NIC to keep things clean. You'll have two for redundancy. Here's my virtual switch. Here's my port group. Okay. Now, what's different here? Inside this VM, I'm going to load a special driver. a driver to actually do all my 802.1q trunking. It's going to be an 802.1q trunking driver inside the OS of that machine, if it's a Linux or a Windows or whatever. Now, all the tagging and untagging will occur inside the virtual machine. Okay. Now, you might be wondering, why would I want to do this? Okay. Well, first of all, let's back up the picture here for a second. I don't care if it's virtual switch tagging or external switch tag. I don't care which one you're doing here. But let's say I got this VM right here. And let's say this VM, I want this VM to be on 2 VLANs. So I want it to be on the VLAN 10 and I want it to be on VLAN 20. What I'd have to do to that VM is give it a second network card, second virtual NIC, and then connect it to that port group. So again, the same thing in this example. If I wanted to do that, I'd have to give it a second NIC and then connect it to that port group. So one of the questions I usually ask is, well, what's the maximum number of networks of VM? What's the maximum number of VLANs a VM can be on? And usually I get everybody kind of silent. Then I'll usually say, what's the maximum number of network cards a virtual machine can have? And we haven't talked about that, but again, a VM can have up to 10 virtual NICs, up to 10 vNICs. So that tells me a VM can only be on 10 VLANs max. Okay, so if I've got a VM for whatever reason it needs to be on more than 10 VLANs, virtual guest tagging is one way to achieve that. Maybe this is some kind of security appliance sniffer or whatever. Okay, I've never run across anybody doing this, but anyways, I'm sure there's people out there doing it. Leave comments below on what you used it for. So this is kind of cool. Inside the VM, you put this trunking driver in, and then you program in the VLANs you want, 10, 20, 30, 40, 50. And the VM does the tagging and untagging of the packets. Now, in order for this to work, this port group here on the virtual switch has to be special. Remember we looked at the port group and we saw the VLAN, right? If it's a standard switch, I got to set it to VLAN 4095. It'll be basically, it'll say all 4095, okay? So you select that. And then that means all VLANs will go through this port group. If it's a distributed switch, vSphere distributed switch, in the vSphere distributed switch, you have more granularity. I can specify the range. I can say VLANs 10 through to 100. So you can specify that range if you want. The other thing we got to keep in mind, again, here's the virtual switch hooked to this uplink, right? The physical card, physical cards connected to the physical switch. This port on the switch, just like before, has to be set up as a trunk, carrying all those VLANs that you want. Again, if I wanted VLANs 10, 20, 30, 40, I got to, specify 10, 20, 30, 40. Some switches, I've never run into this, but I've read some stuff saying some switches you set it to 4095 and it passes everything. Again, I don't know about that one. I've never run across it, but be aware of that. So these are our 3 choices when we come to VLANning. Okay. We have external switch tagging. Okay. Oops. Whatever. We have external switch tagging, where again we don't need anything set at the port group level. Then we have virtual switch tagging, where again you'll specify your VLANs at the port group level, but then you need trunks out here. And virtual guest tag, and again you'll specify your range or your VLAN here, and again you still need a trunk out here. So the last 2 you always need a trunk in the physical world. NIC teaming and failover. Let's talk about that. So when we go into let me just show you this. So let's go into, I'm going to edit my virtual switch, teaming and failover. Notice I only got 1 card here, so let's cancel that. Let's go into manage physical adapters. Let's put VM NIC 1, move it down. I had them both selected. Come on, Steve. There we go. So I moved VMNIC 1 into, holy cow, let's move them up. There we go. So I have to have them all highlighted. So I got active adapters, VMNIC 0 and VMNIC 1. I'll say OK. And give it a few seconds. You see now I have 2 adapters. So if I go to edit my network, teaming and failover, so they got it called load balancing here. I don't like that term load balancing. It's more load distribution. Notice the default route based on originating port. You can do explicit failover. if I do explicit failover, I basically select my, I move my adapter there. So VMNIC 0 would be my active, VMNIC 1 is my standby, and I'd say okay. Let me move that up. I can specify explicit failover, which is obvious. One card's going to be active, the other is standby. The active one dies, the standby kicks in. The active one comes back, then we start using it. Again, that's where the failback comes in, yes. The other choices you have, route based on IP hash, route based on source MAC, and route based on an originating port, virtual port. I'm going to cancel this. Okay, I'm just going to leave it alone. Let's go back and explain what those are. All right. So let's take a look at that. There's actually another one, route based on physical NIC load. That's only found on distributed switches, vSphere distributed switches. So all these other ones are available on all the other ones are available on all the switches, standard or distributed, but the distributed has the extra one of the physical NIC load, which I kind of like. I'll explain that one. So let's talk about teaming and failover. So I already talked about active standby, right? That's pretty straightforward. The first one here, the default is route based on originating virtual port. So in my example here, I have my ESXi host. I got 4 physical cards. They're plugged into whatever. This could be, 2 separate switches, whatever. I just kept it simple, right? So again, cards plugged into each port here. Notice again, the first VM, we'll call this VM1 over here. This is VM2 and then VM3. Route based on originating port would be basically the port is based on the port that the VM is plugged into. So the host knows, oh, you're plugged into, let's say, port 1. You're going to use this card. Oh, number 2, you're plugged into host 2. It may use this second card. Number 3 is, oh, you're plugged into that. It may use the third card. It doesn't work exactly like that. Number 3 could potentially use number 2, okay? But it's just a very, very simple thing saying, oh, this port will use this card and this card all the time, all right? So very simple distribution. It does not require any physical setup of your physical networks. You don't need to set up like LECP or Ether channel. Don't need any of that stuff. You can just plug in the cheapest switch you could find in here and it will work. So this is very simple, very low overhead, and it's one of the recommended solutions from VMware. Why? Because it has no hardware dependency, it just works with everything. Okay, and again, let's say this VM is using this card fails, it may fail over to whatever, this card here, right? And then when that card comes back, or let's say the cable's unplugged, it could fail back. Remember that setting, fail back, okay? So route based on originating port, very simple. That's the default, okay? Then there's route based on source MAC. This is almost exactly the same as the port based. This VM has a NIC right here, and it has a virtual MAC. Same thing with this guy, it has a MAC. So the host is going to say, oh, this MAC address, I'm going to pin it to this card here, let's say, this uplink. This MAC address, oh, I'm going to pin it to this card, let's say, right? And this MAC address, maybe I'll pin it to that card. So it's pinned based on the MAC address of the VM. Very similar to port base. They're almost exactly the same. The only difference here is if you have multiple MACs inside the VM, then potentially you could be using multiple NICs. Potentially, okay? Again, very simple algorithm, no configuration required out here. LACP, don't need any of that, Ethernet, don't need any of that stuff. Very simple. Now, the other one here, route based on IP hash. Now, the ones I just explained, the route based on MAC or route based on source port, this VM here generally is going to, let's say, use that card all the time. That NIC will use that card all the time, right? So that might be a bottleneck. Route based on IP hash is based on the source and destination IP. So again, this VM here has an IP, and let's say we're talking to some machines out here, right? Whatever. So if the VM here is talking to this first machine, it's got a source and destination IP. It may use this link. Now let's say this same VM is now going to talk to the computer down here. Same source IP, different destination. It may use the second card to get down there, and so on. So source and destination IP, you can look and say, oh, the VM can now use multiple NICs. I can potentially get better performance, which is really cool, right? Obviously, if the VM is talking to just one device out there, it's limited to the one card. There is something else that's required. In order for this to work, since I've got 4 cards here, I now need to set up link aggregation control protocol. That's 802.3 AD link aggregation. So I have to set up LACP across these NICs here that these cards are plugged in. So that requires you to pick up the phone and talk to the network folks, okay? And they need to configure that. So that's kind of one of the downsides of it. Does your switch support this? Right now, I know most everybody's going to say, oh, every switch support this. No, they don't, right? Depends on your environment. You're a small mom and pop shop. You may have a very basic switch. You're doing stuff like that, okay? So, again, totally up to you. Also, you may not be a network guy and you go, I don't even know how to set that up. I don't even want to mess with it because I don't even know how to troubleshoot it, right? So it's totally up to you. Again, I usually get into battles with some network guys sometimes. Oh, no, it's got to be LACP. You got to do it like this, especially when I start talking the NSX stuff. And basically, it's going to come down to what's your comfort level on troubleshooting, right? Because, again, there's different switch vendors out there. When you go to call up VMware support, again, if they start to troubleshoot and they think it's the switch, basically at that point, you're pretty much almost on your own. So they will help you out. Don't get me wrong. They will help you out as far as they can, right? But again, so watch out for that. So again, bottom line, these are options that you have. The last one is route based on physical NIC load, which I kind of like. This is only available as an option on the vSphere distributed switch. So it's not on standard switches. Let's say I've got, and again, this basically does not need LACP or anything like that. It basically, see, a route based on originating port, that's the default. It's basically a variation of that. So remember, let's say a route based on a port, this VM's using this NIC, this VM, let's say, is using that NIC, and let's say this VM's using this NIC, right? Now, let's say the first NIC is overutilized. It's, it's sitting at 80%, 90% utilization, and this one here is at 10% utilized, and this one here is at 20% utilized, and this one's at 0, right? Too bad. There's nothing that it doesn't know any better. Route based on originating virtual port, it's going to say, sorry, it doesn't take this into consideration. With the route based on physical NIC load, it will look and say, hey, you know what? We're over 75% utilization. So basically every 30 seconds it looks at the NICs and it says, oh, if this NIC is at over 75% utilization, it then says, you know what, I better start moving some VMs around onto different NICs. So it's sort of like intelligent port base. Now in this example, there's one machine sucking it back. Let's say there was another VM down here. Actually, sorry, let's go to my example here. Let's say, there was another machine here. Let's say these two VMs were using this NIC, and now we're sitting at 90% utilization, right? It would say, oh, okay, I better redistribute stuff. Maybe it will move one of them from here and maybe put it onto the second NIC, let's say. That's an example of it. So that's kind of neat, all right? That's kind of a neat algorithm that you could use. The last thing, and then I'll do a demo of a distributed switch. The last thing is teaming and failover. Sorry, we already talked about that. Last thing is network detection failure. How do we detect failures? Well, the default is link status, okay? Link status, basically, link status is, sorry about that. Let me go into, let's cut. Okay, start from here. All right, so let's talk about network failure detection. Okay, so network failure detection, we've got two choices, link status only or beacon probing. So let's just go and show you how to set that up just real quick. I'm going to edit my switch. I'll go to teaming and failover. And over here, network failure detection, link status only or beacon probing. Link status only is the default. Let's cancel that. Let's go back to my iPad. So link status, when I look at this picture here, this NIC, the ESXi host is looking at the link state of that card. In other words, is the link light on? Yes, it is. Great, it's good. No, it's not. Somebody's broken that cable or unplugged it. The link's out. It's bad. So fail over to the other ones. Pretty straightforward, okay? The problem with link status only, the problem with this one is great. If this link up here fails, so I cannot get down to this physical NIC. We don't detect that failure, right? So that NIC light would still be on. So we're going to be sending packets out of there, and it's not going to get to its destination. So the host is going to think it's good because the link light's still on. Now, there's a thing called link state tracking. It's a feature of a switch. So generally what happens here is you may have this port on the switch here. Sorry, let's look at this one. You may have this port on the switch, and what you'll do is you'll set this up as a group almost, a link state tracking group. And you'll say if this port here, this upper port here dies, turn off this port. So at this point, if this cable breaks, the switch knows to turn this port off. And at that point, this link light goes out and we detect the failure. So we're able to detect upstream failures if your switch supports a thing called link state tracking. Now be careful. Not all, I think most switches do call it link state tracking. I'm not going to say all of them do, because I actually, my IBM days, IBM sold switches. Yeah, they did. And we didn't call it link state tracking. They call it trunking, right? Trunk failover. And I was like, what? That's not a trunk. Anyways, yeah. But they called it that. So watch out. Your switch vendor might call it something different, but that's what you need. Now, suppose if you don't have link state tracking capabilities. Suppose if you don't have link state tracking, that's where you can select that beacon probing. So beacon probing, it sends out so it's sort of like a software detection method. It sends out a 62-byte packet every second to everybody in the team. So this guy's going to send out one, send out one, send out one, send out one, right? You need at least 3 NICs. And what happens here is we have to receive the packets from the other ones. And if we don't, then we know we're bad, and we actually have to, turn off that link at that point, or fail over at that point. This needs at least 3 NICs with 3 separate switches. That's the minimum. Okay. Imagine if you had just 2 NICs here. Let's get rid of this. And you're doing beacon probing, right? And again, the packet's got to go around to get back to the other NICs. Well, if you put a break in the cable here, which NIC is bad? I don't know, right? So it only works with at least 3 or more. Okay, so this is kind of a software solution if your physical switches don't support link state tracking. If they do, use link state tracking. It's much better. Okay, folks, and that's the default setting. But again, if you got some kind of mom and pop cheap switch that doesn't support that, then you might want to look at links at beacon probing. Okay, so that's it. Now, let's do something here. I talked about distributed switches, but I didn't get a chance to show it to you. Let's go in and create a distributed switch right now. So one of the things I got to be aware of is my vCenter server is on host 1, and host 1 is using these 2 NICs here. My other hosts don't have any VMs, so I don't care about it. I'm not too concerned about other VMs. I'm concerned about the vCenter server, and you'll see why in a second. So let's go into our networking view. Again, to create a distributed switch, this is at the data center level. It's not a host configure, it's the data center. So let's right click on our data center, say distributed switch, new distributed switch, and I'm going to give it a name. I'm going to call it Site A-VDS-01, Virtual Distributed Switch 01. I'll go next. It's asking me what version distributed switch do I want. This is going to depend on if you've got a mix match of ESXi hosts out there. So for example, if I had like 6.7 hosts and 7.8 and 8 hosts, and I want them all to be on the same switch, I got to pick the lowest common denominator. Again, I can upgrade it afterwards. It's easy peasy, right? I'm going to say version 8 because that's all I'm doing. I'm going to go next. Network offload is about these data processing units. I'll talk a little bit about that, but we have the ability to offload network stuff now in version 8 to these data processing units. I'm just going to leave that alone. Maybe I'll do a separate video. Now, the uplinks, what you have to ask yourself here is, of all your servers, like for example, in my environment here, I've got 3 servers, and each server only has 2 NICs. So what's the maximum number of uplinks that I need? Well, what's the maximum number of uplinks each host is going to add to the distributed switch? So in my case, it would be 2 NICs from each host, so the maximum uplinks would be 2. Again, if I had a mix match of hosts, I had this host with 3 NICs, that one with 4, that one with 5, and if I want all the NICs to be on the distribute, I would have to say 5 over here. And then I can add them specifically for each host as a configuring. Network I/O control, I'll talk about that in a separate video, but again, we'll leave it enabled. Do I want to create a default port group? Since I'm migrating everything across, yeah, I'm probably going to make a default port group. Since this is my first one, I'm going to actually I'll call it PG-management. Okay. And I'm going to click next. And then it gives me a summary. I go finish. So there's my distributed switch. If I open it up, you see there's that port group management. There's a reason why I made management here, because I'm going to migrate over. Remember, if I go back to my host, if I go back to host 1 here, my virtual switches, my vCenter server is actually on a port group. So I want to put it on a management port group, right? So let me go into here. Let's go into the VDS. Let's go add and manage hosts. Now here I get a choice. Add host, that's what I want to do. Or manage host network. If there's some existing hosts there, I don't have any. Or do you want to remove hosts? Again, we're adding. So let's go next. Now I'm going to pick the hosts, all the hosts I want to add. I'll pick them all. I'll go next. Now it's saying what network cards do I want to add to the host? Okay. And this is where it can get a little fun. And the reason why I'm saying it can get a little fun, normally this is easy peasy. The reason why it can get a little fun is my vCenter server is using one of the NICs on ESXi01 right now. And if I rip it all away, vCenter server is going to lose connectivity with the host, and it's going to cause the host, this configuration, to roll back, so it won't work. So I got to leave one NIC there at least, so vCenter server, and then I can manage it afterwards. So let's say we're going to assign VMNIC 0. Sorry. Let's go back to, let's close this, sorry. VMNIC 0 will go to uplink 1. I'm not going to bother assigning the second NIC, okay? I'm going to leave it alone. Can I actually be specific? Yeah. So you notice my VMNIC 1 is actually on switch 1 on my first host. So my vCenter server potentially could use that for communication. So that's good enough for me. Let's try this out, and I can add that NIC afterwards. The only reason I'm worried about this is because my vCenter server right now is on one of the hosts I'm migrating here, and if it loses connection, it can't talk to the other ones. It's going to say roll back everything. So it tells the host, configure this. If you don't hear from me after so much time, roll back. Okay. So I'm just going to go next. Says VM kernels. Oh yeah, it's talking about my VM kernel port, my management port on each of my hosts. So where do I want to assign that? VM kernel 0 of each host. Again, I'm going to put that on the port group called management, and that's the reason why I made that. So it says, oh, okay, it's going to go from the standard switch port group to the new distributed switch, so we'll be able to talk to each other. So great. I'll go next. I'm not going to worry about migrating VMs. I'll go next, and then I'll go finished. And let's see what happens here. Okay. Update network configuration. Oops. Update network configuration. It looks like it's complete. All right. So let's check out a couple of things here. Let's go into host 1. It's probably going to give me an error here. Something on, yeah, network uplink redundancy loss. Hey, yeah, because I just ripped an adapter out. That's okay. So if I go to host 2, let's go to configure. Let's go to virtual switches. You see here, there's 1 and 0 NIC adapters. Oh yeah, sorry, the distributed switch. It's got, again, the uplinks. Okay, it's got 1 NIC adapter and it doesn't have a second on the uplink. So if I go back to here, again, this one here, I get the same thing here. My standard switches on them have no physical adapter. So basically, it's ripped the physical adapters from the standard switches and put it on the distributed switch. So that's great. I could actually go to my standard switch on host 2. Let's go, and I can remove it. Yes. Give it a few seconds. It's gone. Host 2 now only using the distributed switch. Same thing with host 3. I can go to the standard switch. Let's open it and remove it. And then give it a few seconds. And now host 3 is only using the distributed switch. Can't do that with host 1 yet. Why? Because, again, if I look at my standard switch, there's the distributed switch. If I look at my standard switch, I got a virtual machine using this. And that's my vCenter server. So I need to migrate that across. Okay? So one simple way for me to do that is edit the virtual machine. Let's right-click, edit settings. Let's go into the network adapter. It's on VM network, which is that standard switch. Let's put it on port group management, which is the distributed switch. And I'll say, okay, we'll give it a few seconds. Bingo bambo, looks like we're good. Okay, Let's just confirm everything moved over, edit settings, and we see it's on port group management. Beautiful. So now my ESXi host, right? Again, look at the standard switch. There's no VMs on it, but it still has that one physical adapter. So let's go into this switch here, physical switch, and let's remove it. Yes. There we go. So, and there's that other standard one I created, that bogus one I created earlier on. Let's remove that. And yes. So right now, all my hosts are only using the distributed switch. However, there's only one uplink from each host. Okay. Notice this says uplink 1 is 1 network card, uplink 2, 0 network cards. Let's go in and edit or manage our host. Let's right click on the distributed switch. Sorry. Right click on the distributed switch. Add manage host. Let's say manage host networking. Let's say I'm going to pick all those. And then notice here VMNIC 1, it's not assigned to anything. Let's put that on uplink 2. Let's go next. VM kernel 0, assign port group. Well, we already did that. So we'll leave it there. We'll see assign. Okay. And then we don't need to worry about migrating VMs. So we go next. We go finish. And at that point, we give it a few seconds. And we should be good to go. Let's go in and look at our host now. Let's look at host 2 there. Now you see it. Host 2's got 2 NICs on the distributed switch. Host 3 has 2 NICs on the distributed switch. And host 1 has 2 NICs on the distributed switch. So I'm now using distributed switches in my environment, right? So, and what is the advantage of that? Let me show you. I'm going to right click on distributed switch. I'm going to create a port group. I don't want to add hosts. Let's create a port group. Distributed port group, new port group. I'll call it whatever, production. And I'll go next. And I'll just leave all the defaults and go finish. So now I can actually go in, right click on the port group and edit settings. And I can now create my, modify my teaming policies if I wanted to. I got a lot more options here for security and stuff. I'll talk about that maybe in some of the other videos, right? Well, VLANs, I can manage this. VLAN trunking, private VLANs, monitoring. I got a lot more capabilities I can use now on distributed switches, right? And the advantage of this, that's one thing, is I can actually have, under miscellaneous, I can actually go in and block all ports, no. I can say yes. I can actually go into the individual ports and block ports if I wanted to. So I have a lot more granular control with the distributed switch. And I can all I have to do is make a change right here, and that change applies to every host that's part of this distributed switch. Whereas the standard switch, remember, we had to do it one at a time, right? So that's one of the big advantages here. That's it, everybody. It was a long video. I hope you learned a lot. Again, there's still some other stuff that you can learn there. But again, if this is the stuff you like, please subscribe to the channel. I'd really appreciate it. If you found this a little bit entertaining or useful, hit that thumbs up. I'd very much appreciate that as well. So till then, we'll see you in the next one. The next one's probably going to be on storage. Okay? See you then. Bye-bye.